That's a bit strange. Right, let's start. I deliberately wanted to start with a single mass question, quite simply because there's a large number of learners over here that are still coming to terms with Newton's second law, and there are some grade 12 learners that would like a quick refresher on everything as well. Just want to double check something.
Yeah. Yeah.
Okay, please mute yourself when you come on, because everybody can actually hear you talking in the background. Right, a constant force F pulls a 50-kilogram block at constant speed. And that's the key word we're going to basically deal with here. Constant speed. What does constant speed actually imply, anyone? It implies that the net... Very good. It means that the net force acting on the object is going to be 0. It's moving over a rough horizontal surface AB, as shown in the diagram, and you are given the coefficient of kinetic friction between the block and the surface to be 0.4. So you're given your mu k value here to be 0.4. Draw a labeled free body diagram of all the forces acting on the object. Now, please note, you've got an applied force here that is actually acting at an angle. And I think by now everybody knows my general sort of plan of attack when I'm drawing a free body diagram is to take any force acting at an angle and break it up into components. So there is your x component of your applied force, and there's the y component of the applied force. So I don't like putting in the applied force. I like to put in the components of the applied force. Then you're going to have your usual forces acting on it, which is your gravitational force, your normal force, and going backwards here, your kinetic frictional force. Now, we've technically got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 forces here, but they've given you 4 marks. And remember, the reason why it's got 4 marks is because we took the applied force and broke it up into components. So we ended up with 1 additional force when we actually break it up into components. I'm not going to state Newton's first law for you, but this is a hint that this question here deals with Newton's first law of motion. And Newton's first law states that if the net force is 0, then the object will either remain at rest or move at constant velocity if it was already in motion. So here, obviously, we had an object in motion, and your net force on this object is 0. What does it imply? It means that the sum of the forces in the y direction are 0, and also the sum of the forces in the x direction are also 0. So if you sum your forces in either one of the 2 directions, you're going to end up with 0 newtons here. Calculate the magnitude of force F. Now, we won't be able to get that directly because we don't have F here. But if we can calculate Fx or any other force, we should be able to do this. And I want you to look at the mark scheme here. It's 6 marks, which means this can't be an easy question. So although we're starting off with a single mass system here, to get the force is pretty difficult. So how are we going to do this? Because your net force is 0, it means the sum of the forces, sorry, let me just write this down properly. That's 3.3, that's 3.1, 3.2 was a theory question. The sum of the forces in the x direction is 0 newtons, and the sum of the forces in the y direction is 0 newtons. Can I just make a plea to the learners that are in charge of these groups or the learners that are on these groups? Can somebody put down a message that the lesson has started in the grade 11 GC group and the grade 11 tuition and the grade 12 tuition group? Because I think there are more people that want to attend, but I think they've forgotten the times. So please just remind them. Thank you.
Oh,
Please
I'll
mute
play.
yourself. Somebody's got their mic on in the back there. Thank you, sir. Right, let's go back here now. We need to find out what fx is, because if we got fx or fy, we can actually find f. Any idea how we're going to do this? No one. This is not an easy question, by the way. It's a pretty difficult question. So please listen up. I'm going to start off with the sum of the forces in the x direction to be 0. And here's the first equation. Your fx here will equal to your kinetic friction. These two forces have to cancel out each other. And what is fx? It's f cos theta. And theta is 20 degrees. So it's f cos 20 is equal to your kinetic friction. That's equation 1. Then you can do the same thing in the y direction. In the y direction, the two forces acting upwards, these two here, the two forces acting upwards is equal to your gravitational force here. So the second equation that I'm going to set up for the y direction is Fy plus Fn is equal to Fg. Fy is F sine theta. Fn, I don't know what it is. And Fg is Mg. So this is going to be F sine 20 plus Fn. Your mass over here is 50 times 9.8. I shouldn't have started with this question. It's actually a pretty nasty one, eh? Probably scare some of you away. All right, coming back here. That's going to be F sine 20 plus your normal is equal to 49. Anybody knows what I should do next? I'll allow you to read the question again to give you some idea as to what to do next. Because there's one crucial thing that you need to do that will allow you to solve for for F over here. Now, this, in my opinion, is not a 6-mark question. It's quite likely an 8-mark question. But I think the examiner knew most of the learners were going to get this wrong.
So why is it 49?
Thank you. 50 times 9.8 is not 49, it's 490. Is that correct, sir?
Yes, sir.
Okay, let's go back. Anybody knows what's the most crucial thing you need to do next that will actually allow you to solve for F? Right, let me tell you what it is. You need to make Fn the subject of the formula, the normal force. That's going to be 490 minus F sine 20. I suspect that the guy who set this question didn't realize how difficult it is, because he wouldn't have said it as question number 3 in an exam paper. This was in a grade 11 paper, by the way, not a grade 12 paper. But it was a nasty question. Anybody knows what I'm going to do with these two equations now? Because it gets even weirder from here. Anyone?
Simultaneously solve it.
Well, you can't solve anything simultaneously over there because you can't equate those two equations. Right, let me show you what you need to do. There's an equation that relates your kinetic frictional force to your normal force. That's a third equation that you're going to use. I'm going to put this in red so you can see it. Your kinetic friction, which is there, is equal to mu k, which they gave you, the coefficient of friction, there, multiplied by your normal, which is here. Now you can take these two equations, the one for Fk, plug it in place of Fk, the one for N or Fn, plug it in place of N. You got your mu k to be 0.4, and you'll now be able to solve for F. Now, I don't think many learners would have seen this. So you're going to call this equation 3. Somebody actually weirdly asked me in school today, can we actually get a simultaneous equation with 3 equations in it? Weirdly, I actually chose, and I didn't realize it. I mean, I just randomly chose a question thinking that I'm starting off with an easy question for everyone here, and it'll be a nice place to start. Not realizing it is actually not a good place to start. It's horrible. So in place of Fk, what do I put now? So you sub equation 1 and 2 into 3. As I said, this was not a good question to start off with. I didn't realize it was so difficult. So in place of Fk, F cost 20. In place of mu k, here, 0.4. And in place of your normal, there, sorry, in place of your normal, here, 490 minus F sine 20. Now, if you look at this equation here that we set up, I'm just going to put this in a little yellow block here. This equation here has got only one variable in it. And that singular variable is F. So if you plug this in your equation solver, you should be able to solve for F. I'm not going to do all the maths. You don't need it for physics. Plug this into your equation solver and give me the answer for F, please. Anybody's got the answer for F? One of the matriculants, if you can assist as well, please. Well, matrix. Turned out to be a good question after all, isn't it? Anyone? What's your answer there? I can't work this out in my head.
So I'm getting 182,07.
Sounds good. Anybody else? There's your answer for F. For those of you that don't know how to use the equation solver up to now, get used to it, please. Because in physics, we don't give you any marks for any of the maths related to simplifying this and then solving for F. So what did we do again? Just to recap. Sum of the forces in the x direction to be 0. We said Fx equals to Fk. We came up with this equation here. Then we said Fy plus Fn equals to Fg. We came up with the second equation here. So we ended up with one equation for Fk. We ended up with another equation for the normal. We took those two equations, which was one for Fk, the other for Fn, and we substituted it into the equation for your kinetic friction. We ended up with a single variable of F, and the answer for F was 182.07 newtons there. Then they asked us some easy stuff. For example, they wanted us to find the normal force. Watch how easy it is to find the normal now. Why is it easy to find the normal? Because you got an equation for the normal there. It's 490 minus F sine 20. So you just can go straight into equation 2 and solve for this. I need another page. I'm going to take this up. Okay. So from equation 2, so this is question number 3.4 now. Your normal is 490 minus F sine 20. The normal force is 490 minus F sine 20, which is going to be 490 minus 182.07 sine 20. What's the answer for the normal there, anyone?
So I'm guessing 427.73.
427.
728, 3 decimals.
So there's 3.4 there. 3.5, the frictional force. There's it there, equation 1. So if you set up everything neatly and nicely, these 2 marks would have been easy to get. But that's 6 marks on the top. You would have sweated for that. Even a grade 12 learner will cry for that one. So your kinetic friction is F cos 20. How often do they test such difficult questions? Yo, it's actually a rarity with one mass, eh? Normally single mass questions are straightforward. So 182.07 multiplied by cos 20.
So 171.089. The fourth decimal is an 8.
So 09.
Yes, sir.
Okay. There's your kinetic frictional force, which is pretty huge, eh? And there we are. This, in my opinion, and I didn't realize it, is one of the most difficult questions I've come across for a single mass system. My apologies, grade 11s, especially for you guys. I didn't realize that actually starting with this question would be pretty nasty. It was not my intention to do a difficult question at the beginning. But at the same time, it's also good because our grade 12 friends will catch a wake up and realize, hey, you can get some horrible questions here. Right. If the same constant force F is now applied to the block over the same rough surface as before, but in the direction shown, give a reason why the block will move slower than before. Now, here's the reason why. Here, your normal force is 490 minus F sine theta. Here, the normal force, if you redraw the free body diagram, I'm going to redraw it for you. You have a downward applied force now, which means this is what happened with the downward applied force. Your Fy went down. your Fx went here. Still the same Fx. Your gravitational force is still down. Your normal force is here. And there's your kinetic frictional force. I want to just show you what happens to your normal force here. From this diagram, your Fn is now equal to Fy plus Fg. So your normal force here is F sine 20 plus the 490. This is for your new diagram. For the original diagram, your normal force was 490 minus F sine 20. You may be wondering, so where are you going with this argument? 490 minus F sine 20. Anybody can see where I'm going with the argument? No one. Your kinetic frictional force is equal to mu k multiplied by your normal. So your kinetic frictional force is directly proportional to your normal. You've got a larger normal here because it's 490 plus F sine 20. You've got a smaller normal here. Because it's 490 minus the same F sine 20. What does that mean? It means if you've got a smaller normal, you're going to have a smaller kinetic friction. If you've got a larger normal, you're going to have a larger kinetic friction. So in the new situation, Fk is larger. Therefore, moves slower because there's more friction. Look at the question now. Give a reason why the block will move slower. It will move slower here because the frictional force it will experience when you're pushing it will be much larger than the frictional force that you will have when you're pulling it. And the reason for that is because the normal force originally is smaller because you're subtracting F sine 20. And this new normal force is bigger because you're adding the F sine 20. This question here would have finished off the grade 11s on Newton's first law. Even the grade 12s, I would guess. It is just not a good question. Let's hope the next one is easier. It looks easier. It is easier. Thank God for that. Right, let's go for it. Sorry about that. I should have actually started with this one. 16 marks here. 18 marks there, just about the same. You would have sweated through those 18 marks there. You'll comfortably glide through these 16 marks here. It will be much easier. Why? Because in this question, they gave you the applied force. They didn't do that in the previous one. You have to work it out. Right, let's go for it. A box with a mass of 45 kilograms is pulled with a force of 90 newtons at an angle of 50 degrees to the horizontal. And once again, the box moves at constant velocity. I'm trying to do all the Newton 1 questions first today. Because it's moving at constant velocity here, it means that your F net acting on this box is 0. Define kinetic frictional force. I'm pretty bad with these definitions. Please boys and girls, make sure that you learn the definitions. The grade 12s, it was already given to you. The grade 11s, I'll put up a whole set of definitions for Newton's laws towards the end of the section. State Newton's first law of motion. Yeah, two definitions here. An object will continue in its state of rest or uniform motion in a straight line unless acted upon by a net or resultant force. Very kind examiner. Calculate the magnitude of the horizontal component of the applied force. 3.3. Very, very kind. They want us to find out the fx here. Fx is f cos theta. Please give the answer to 2 decimal places. There's no need for 3 decimal places. They want the magnitude of the horizontal component, so we don't have to give a direction. It's 90 cos 50. 90 cos 50, someone?
57,85.
Thank you. Calculate the magnitude of the normal force. Actually, what we should have done, even if before we worked out 3.3, my mistake, draw the free body diagram. They didn't ask you for that here. Always draw it. There's my object. There's my fx. There's my fy. There's my normal. Yeah, this is the one I should have started off with. There's my fg. And my kinetic friction. Any questions about that? None. So, how are we going to get the normal? Well, here, the sum of the forces in the y direction are going to be 0. So, Fn plus Fy is equal to Fg. And the examiner kind of gave you a hint in 3.3 not to forget Fy. How did they give the hint? They said calculate Fx. So 3.4, your normal plus your y component is equal to Fg. We're going to find that normal now by saying that's equal to Fg minus Fy. Fg is mg, Fy is F sine theta. Your mass, 45 times 9.8 minus 90 sine 50. Right, what is the answer for Fn here?
372. 372,056.
0.6. So we got our Fx here, and we got our Fn here, which means the next question should be to calculate the coefficient, exactly what I predicted. Why? Why would it be the coefficient? Look, on this diagram, it's supposed to be drawn accurately, but it's not drawn very accurately. Your x component of the applied force is going to equal to your kinetic friction here. So we got what the kinetic friction is. So for 3.5, to find out the coefficient of kinetic friction, that's what they want us to find. We got our Fx equal to your kinetic frictional force. And that's going to be F cos theta is equal to Fk. Your F, oh, we already worked out Fx. There's there, 57.85. Your normal, we got it there. So to get your mu k now, we go back to the equation for kinetic friction, which is your mu k multiplied by n. You're going to put 57.85 here. is equal to mu k, which is what we want to calculate, multiplied by your normal, 372.06. So
So
57,
0.16.
sorry, 0.16. Thanks, sir.
Yes.
And then the last one should be a nice simple theory question. Will the coefficient of kinetic friction change if the angle of the applied force is decreased? Will the coefficient of kinetic friction change? Anyone? Yes or no? The answer is no. What's the only factor that will change the coefficient of kinetic friction?
So that's the surface of the, yeah, it's the surface.
Very good. It's a type of surface you got rubbing over each other. I didn't tell you that they changed the surfaces here. So the coefficient will remain the same. So 3.6. Will the coefficient change? No. And the reason? The surfaces are the same. Now, my aim is also not to dwell on Newton's first law. My aim is also to go on to Newton's second law, and I deliberately also chose this because this is a nice, easy start for a double math system, which I'm certain you've all actually started in school, and you may have even gone on to either inclined planes or other objects where you, or other systems or scenarios where you got two masses. Right, what do we have here? We've got two wooden blocks, mass 20 kilograms and 10 kilograms, placed on a rough horizontal surface. When a horizontal force of 55 newtons is applied to the blocks as shown, the block accelerates to the right. Now, I pointed this out in the previous lesson, and I just want to emphasize this. If your system accelerates in a particular direction, here they tell us that the system accelerates to the right. Let the forces to the right be positive, and any force in the opposing direction will be a negative. Now, the kinetic frictional force between the 20 kilogram block and the surface is twice that of the between the 10 kilogram block and the surface. So I'm going to just do this for now. I'm going to call the kinetic frictional force here 2x. And I'm going to call the kinetic frictional force here x. Because I'm sure they're going to ask us to find out what the kinetic frictional force is because we don't know it. They gave us the acceleration here, boys and girls. So this is a nice question. State Newton's second law of motion. So here, we're not going to be using Newton's first law because we're definitely going to have an acceleration here because it's given to us, which means we're going to have a net force applied on each mass. This examiner was very specific. It says draw a labeled free body diagram showing the horizontal forces acting on the 10 kilogram block as it moves. Let's start off with the 10 kilogram block. Only tell me about the horizontal forces. Anyone? Can you tell me what the horizontal forces are on the 10 kilogram block? One of them is straightforward, obviously. It's easy.
So a force applied.
Very good.
So friction and tension.
Very good. You're going to have your applied force. There's no components to this applied force because it's already horizontal. And the only other two horizontal forces are your tension. So let's just talk about that tension. That tension acts away from the masses. There's the kinetic friction also acting backwards there. Can anybody tell me why they didn't ask about the vertical forces? They just kind of asked you to leave it out.
Because so the vertical forces are equal to each other.
Very good. The vertical forces will cancel out each other, and the vertical forces will equal to each other. So they do not play any role in the horizontal acceleration. The net force is going to be horizontal. The horizontal net force causes the horizontal acceleration, and therefore you only need to deal with the horizontal forces. Now, I did mention something else, and I just want to reiterate what I said. I said that the examiner will only ask you for one free body diagram. You must ensure that you draw both the free body diagrams. And the reason for that is because you will definitely use the other one. So I actually already have it drawn for you. For the 20 kilogram, there's only two horizontal forces acting. Again, the vertical forces will cancel out each other. Those two horizontal forces are going to be T and your Fk. So the examiner didn't ask for this. So what you should do ideally is do it in pencil. So for the 20 kilogram, now in pencil, you're going to have your tension going to the right and your kinetic friction opposing motion. And here, your F net is going to be T minus the Fk. This examiner was also kind because they don't do this very often. It says, by applying Newton's second law of motion separately to each of the blocks, calculate the magnitude of the frictional force between the 10 kilogram block and the surface. So let's apply Newton 2 to each mass separately. So we're going to go F net equals MA. And we're going to do this for the 10 kilogram block here, which is going to be F applied, which is the positive force, plus minus the tension, plus minus the kinetic friction. F applied, plus minus the tension, plus minus the kinetic friction, equals to MA. I prefer you writing it like this because some of these examiners in trick, they get really faulty when you just say F applied minus T minus Fk, and you just don't know which year. You're going to be saddled with a horrible examiner. I can guarantee you they will accept this though. Do we know the applied force? Yes, we do. 55. Do we know the tension? No, we don't. Sorry, this was Newton 2 for the 10 kilogram, eh? .55 minus T minus Fk. So we don't know the tension. We know that the kinetic friction on the 10 kilogram was X, and your mass is 10. And they gave us the acceleration here. Don't forget that. We're not finding out the acceleration anymore. They told us that the acceleration is 0.36 meters per second squared to the right. So it's 10 times 0.36. Now remember, we need to solve for X. So what I need to get rid of is T. I need to get rid of the tension there. So I'm going to take the T across. So it's going to be 50 minus my kinetic friction. 10 times 0.36 is 3.6, so it'll be minus 3.6. So what's the equation for my tension here? 50 minus 3 is 47, 46.4. Minus x is your T. That's the first equation. Okay, I'm going to move things up a bit here. I'm now going to go to the other mass, which is the 20 kilogram mass. And I'm going to do my F net equals MA for that. So for the 20 kilogram mass, F net equals MA. Your F net there is T plus minus the FK equals to MA. We don't know the tension. We know we call the kinetic friction here 2x, and we need to solve for that. And that's going to be 20 multiplied by 0.36 here. That was the acceleration. So T here is going to be 20 times 0.36, 7.2. Please double check that for me. Plus 2x.
Yes, sir.
So there's your second equation. Now look at this. I got my two equations for T sorted out. I can now solve for x, where x is my kinetic friction. So 46.4 minus x there. 46.4 minus x is T, and 7.2 plus 2x is also T. So that's going to equal to 7.2 plus 2x. 46.4 minus 7.2. What's that? 39.2. Just double check, please.
Yes, sir.
Is equal to 3x. Divide both sides by 3. 13.67. No, 067. No, 67.
Yes, sir.
067.
0.67.
Meters per second squared. Sorry. We're calculating a force here. That force is your frictional force. Let's look at the question again. The magnitude of the frictional force between the 10 kilograms frictional force was called x. And we solve for x. Therefore, the magnitude of the friction is 13.07 newtons. I just rounded it off back to 1 decimal place. We don't need more than, we only need 2 decimal places. We don't need more than 2. Right, there was more than this. Let's see what's the next one. They want the coefficient of kinetic friction between the blocks and the surface. They said blocks and the surface, eh? Now, the truth is, it doesn't matter which block you work with. I'm going to show this to you. Why should it not matter? Because they're both made of wood. They're both moving over the same type of rough surface. So technically, we should get exactly the same coefficient for both these masses. I don't know why people are actually just dropping. But I'm going to show you that I'm going to work it out firstly for the 10 kilogram, and then I'm going to work it out for the 20 kilogram, and you're going to get the same coefficient. Now, to work out your coefficient, you actually need your normal. And for both of these, doesn't matter which free body diagram you use, your gravitational force here is equal to your normal here. And here as well, your gravitational force is equal to your normal. They didn't ask for this, so please don't put this on your free body diagram, eh? You need to rub it out. So I'm going to firstly work out my normal force for the 10 kilogram. What number is this? 14.3.2. Sorry, 4.3.2. So for the 10 kilogram, your normal is equal to Fg. So your normal is equal to mg, which is 10 times 9.8, which is 98 newtons. To work out the coefficient of kinetic friction, you say Fk equals to mu k times n. Your kinetic frictional force, 13.07. Your normal, 98. 13.07 divided by 98, please, someone. 2 decimal places as well.
0.13.
Let's assume we didn't realize that they were the same. And we went ahead and we calculated it for the 20 kilogram as well. So for the 20 kilogram, if you go back to the free body diagram, Fn is still equal to Fg. So you need the normal force again. So we're going to say Fn equals to Fg. So your normal force is going to be 20 times 9.8 now. And 20 times 9.8 is 196 newtons, boys and girls. Then we go back, we say Fk equals to mu k times n. This time though, the frictional force on the 20 kilogram is 2x. We'll take a little bit more of an accurate answer for your friction. So take 13.067 and multiply it by 2, please, to get your kinetic frictional force on the 20 kilogram. You can round that off to 2 decimal places. What's that? 26.13.
Yes, sir.
There's your mu k, which we don't know, and your normal, 196. So 26.13 over 196, we get 0.13 again. We should.
We do.
Thereabout. Why should we get the same UK again? Same wood, same rough surface at the bottom. The mu k can't change. And there we have it there. And then one more question. The rope connecting the two blocks is now cut. Now, if the ropes are cut, that means there's no tension there and there's no tension there. That means there is no force technically applied in the direction of the acceleration anymore on the 20 kilogram. The only force acting on the 20 kilogram horizontally is the frictional force. So what should happen to the 20 kilogram if we basically cut the rope? With the lack of the tension being present and only the kinetic frictional force acting horizontally, the 20
So when it
kilogram should
comes to
actually,
stop,
it will slow down and eventually come to a stop. But the 10 kilogram will still have the applied force on it, but it now won't have a backward tension acting on it. So that should actually speed up slightly more. In other words, it'll have a larger acceleration because you're going to have a larger net force. Now, the net force on the 10 kilogram is just going to be 55 minus the kinetic friction, not 55 minus the tension and minus the kinetic friction anymore. So this will speed up, but that will slow down. How will this affect the acceleration of the 10 kilogram block? Well, we just said it. The 10 kilogram block will now experience a larger net force because there won't be any tension. Therefore, it'll have a larger acceleration. So how will this affect the acceleration of the 10 kilogram block? Increase. And the reason for this, when the rope is cut, T equals to 0 newtons. So your F net will simply be F applied minus Fk. Therefore, F net increases. Then you need to tell the examiner that your acceleration is directly proportional to your F net from Newton's second law. Therefore, A increases. Now that would definitely give you full 3 marks. I don't think they would have a better explanation than that, even in the memo. All right, boys and girls, that brings me to the end of these single mass questions. Tomorrow, sorry, these double mass questions where we got horizontal motion only. And we took kind of difficult questions here. I mean, the first and this third one wasn't so easy. It was a bit on the rough side. Tomorrow I'm going to look at inclined planes and double mass systems. And then I'm going to go on to a horizontal and a vertical scenario where we have 2 masses as well. All right, so hopefully tomorrow I can finish off most of the questions on inclined planes. And if I can, I may start with the horizontal and vertical scenario as well. Thanks for attending, everyone. See you all tomorrow at 8 p.m. Not 7 p.m., please. 8 p.m. tomorrow. Right, we're going to end it here, guys. Great. Okay.